Postulates of Existics, the first 10, is basically where most of the mathematics was derived. So the first 10 postulates of Existics are: 1. Existence is. We're going to just assume, for the sake of argument, that we exist, that I exist, that you exist, that some sort of something binding you and myself in some form or another exists, that we are in something existing and that we exist. I don't see how much more I can be redundant about that, but that is the first postulate. Existence is. Next postulate, something exists. Seems to follow quite logically that if existence is, therefore something exists. Something is one or more things. Something is not nothing, and something is not everything. It's pretty simple. Something is not nothing is nothing more than a statement that one is not none. 1 does not equal 0, mathematically, if you think about it. The statement that something is not everything is nothing more than a definition that some is not all, 1 does not equal infinity, something like that. The statement something is one or more things is just setting a definition that some is 1, 2, 3, 4, some set of values that are neither everything or nothing. What more or less follows but is an assumption, so the next postulate is that for something to exist, it must be an interaction with some other thing that exists. So what we are assuming is that interaction plays a fundamental role in existence, that there is an underlying interaction that is fundamental to existence, and Existics is an attempt to define that fundamental aspect of existence. So, for something to exist, it must be in an interaction with some other thing that exists. What follows from that as a set of definitions, there are at least two things. So basically, if there is an interaction between two things, clearly there are at least two things. So now we are redefining something to a limit that something is at least two things. Now, though we still can have one thing, what we know about that one thing is that it is in an interaction with at least one other thing. Therefore, we're starting with two. So there are at least two things. No two things are exactly the same. So let's say I have, it's obvious, but let's say I have two balls, two basketballs, two baseballs. I can look at these objects, and see that there is at least one thing, there's at least something about these two objects that is not the same. No two things are exactly the same. Okay, now what's going to come from that is the idea that no two things are totally different. For instance, even though this is a square and a circle and they are different, they're both objects written on a chalkboard, or they're both shapes, or they both can be proven using geometry or calculus or trig or whatever. I mean, basically the idea is, even though these are different, we can come up with something that they share, a property that they share. So no two things are totally different. And then, not as obvious is the idea that no two things are perfectly complementary. So an example of that would be assuming that complementary is that 1 over some number n equals m. In this situation, we would assume that they have an inverse relationship to each other that makes them complementary to the extent that n times m equals 1. So they have like a reciprocal relationship to each other. You could think of m as 1 over n, such that when they come together they yield 1. So they're not opposites. Opposites would be more along the lines of 1 over, or I'm sorry, along the lines of m over n equals minus 1, where if we bring the n over, what you end up with is that m equals negative n. So in this case, they would be opposites or totally different. In this case, they are complementary reciprocals. So the idea in Existics is that this is never the case and this is never the case. Now what I mean by this is not that we don't have situations where things are nearly complementary or nearly perfectly different. I'm just stating that in the extreme example, you're never going to have things where, let's say you had a function that covered the differences and or the similarities between two things, that as you carried that function out to a limit, that you would never be able to derive a situation where n and m are perfectly complementary, or where m and n are exact opposites or totally, perfectly different. So let me write out these three situations so I'm a little bit, so it's more clear. We could write out no two things are exactly the same for a situation where a over b equals 1, that meaning a and b, like for instance 5 over 5 gives you 1, so where a and b are identical, you get 1. We'll say that this is not ever the case. For the statement no two things are totally different, what we'll do is we'll put a over b equals minus 1, and this can represent them being perfect opposites, that more or less being the mathematical equivalent to the statement that I make when I say no two things are totally different. And then the third, no two things are no two things are perfectly complementary. That'll just be a equals, no, it's not going to work. A equals 1 over b. Or b equals 1 over a. What these three statements are stating is that with the rules of existics, we're never going to have a situation where two things are identical. We're never going to have a situation where two things are perfectly different. And we're never going to have a situation where two things are exactly or perfectly complementary. From these 10 postulates of existics, we can go ahead and start to derive and lay out the mathematics that goes along with it.